Hi everyone, this is Hitesh. Welcome back to the channel again. So today we are covering one of the most commonly asked Android interview topics, that is what are solid principles. And these are one of the topics, this is one of the topic that helps us to understand how can we follow the coding standards and how we can avoid violating the coding principles. So let's begin. So we'll try to understand the meaning of each one of the letters, what does it mean, and what is the usage of each one of them into the Android coding development. Let's start with S. So S stands for single responsibility, which says that the single responsibility principle is basically states that a class should have only one reason to change, which means it should have only one responsibility. With SRP, we get the following benefits. One is it's easier to understand, it's easier to maintain, and it's easier to test. Simple example I would say is MVVM when we use, right? That is model view model. It has its own responsibility. Let's say we have a domain layer, we have the data layer, and then we have the presentation layer. So all these three layers have their own responsibilities. None of them try to hamper any other's responsibilities. Each one of them has been designed to follow certain rules of their own. And there is one more example, which is recycler view class. So let's try and understand how this single responsibility works around using an example. So there is a class called printer, and that has two functions, function generate and function print. All right, now this class itself is having multiple responsibilities. It is going to do these two things, which basically is not following the SRP principle. What if we segregate these two functions into two different classes, like class PDF generator, which will have a function called generate, and then class PDF printer, which will have the function to print. So each one of the class will have its own responsibility to perform certain actions. Or we can take another example. It is like this class RV class that extends recycler view, right? So guys, you know that whenever we extend the recycler view, we have the three override functions. One is onCreate view holder, the other one is onBind view holder, and then the third one is get item count. Now single responsibilities, as it says, that each one of them has their own responsibility. Assuming if in onCreate view holder, instead of just inflating the view, if I start performing some more action, or in case of onBind view holder where we are supposed to bind the views, we do some heavy operations, some calculations or something else, so that is definitely going to violate the SRP, the single responsibility principle. But instead of that, if we only focus on inflating the view on create view holder and just adding the or just binding the views on bind view holder, then it will certainly follow the solid design principle S, that single responsibility principle. So that is what S stands for. Now moving to O stands for open closed principle. So the definition says that the software entities like classes, modules, functions, etc. should be open for extension but closed for modification, which means that you create any class which will perform any kind of function, right? So that particular class should certainly be closed for modification and should be open for extension. That means if I try to remodify the same function for my new requirement, that would be the place where I am violating the code and I am violating the principle of O, that is open close principle. I am trying to modify the existing functionality rather than creating another class and extend that parent class to that particular class. Now with OCP we get the following benefits. One is prevents introducing bugs into existing code when new features are added, as I have said now, and makes code more maintainable and scalable. We will understand this with an example. It will be much more clear to you how this OCP works. Now let's say there is a class, open class logger, which has a function save logs in txt format. So this is a main class which will save the logs for the entire application in the form of txt format, right? Now assuming there is a new requirement coming up which says that all the new modules that you will be developing in the coming future, you have to save those particular logs into exe format rather than saving into txt format. Now if I don't follow this OCP, open close principle, then certainly what I will do is I will try to modify the existing function, and then I will try to save the file into exe format instead of txt format. Now what would be the result? The result would be all the existing functions or the modules that are using this particular class, which were planned to save everything into txt format, will also now be saving into exe format, which is certainly we are violating the OCP principle, which ideally we should not be doing it, because what is the purpose? I mean, I don't want to save the entire application ka logs into into exe format. It is just meant to be saved only for the new models. So what can I do is I can create a new class exe logger, and then I can extend the class logger with it, which will give me override function save logs in txt, and now I can save the logs into exe format. So in all the new modules, wherever I want to save my logs into exe format, I will use this class, and in all the existing modules where I was saving the logs into txt format, I will keep on using the logger class. So this is how the OCP is used. This is how we can avoid violating the open close principle by only allowing the class to extend it rather than modifying it. Alright, so now let's go to the third principle that says L is Liskov substitution principle. So the definition says that the objects of a superclass should be replaceable with objects of a subclass without altering the correctness of the program, which means that if you create a parent class, let's say, and then you create a child class, now in the child class, when you're going to extend the parent class, like for example we extend the activity class, right, in our own custom classes, so we are basically overriding the functions of the parent class. But if anything happens that basically breaks the actual implementation of the parent class, that would be the place where we will violate the Liskov substitution principle. We should avoid altering the correctness of the actual program. So with LSP we get the following benefits: more predictable code and prevents runtime errors. How? Let's see an example. So if you see, there is an open class vehicle that has two functions. One has tires, one has motor. All right, so assume like there will be certain implementation that will be added for has tires, and then same functionality or some implementation that will be added for has motor. Now this is my parent class. If I create a child class called car, which I extend with the vehicle class, that is the parent class, and I will have the override implementation that has tires and has motors, and which makes sense. I mean, car will obviously have the tires and it will also have the motor, which is fine. But now I'm going to create another class called bicycle and extend the parent class vehicle, which will have the same two override functions. And if I see here, has motor will throw an exception for me. Why? Because bicycle will not have has motor, right? So I manually want to return some exception saying that whenever I use bicycle class, which is extended by vehicle class, I have to return some exception because bicycle will not have the motor implementation anyways. All right, now you go to your main class, you create a function and you try to create the objects, one for car and one for bicycle. Now if you see object 1, you will be able to call these two functions as tires and has motors, and they will be called and executed correctly. I mean, there will be no issue. But when you do the same thing with bicycle, object 2 dot has tires and object 2 has motors, so here has motors is going to return exception, right? Because that is where you actually added an implementation saying that it should throw an exception because bicycle will never have the motor implementation. All right, so that is the place where we are actually violating the LSP, Liskov substitution principle. Instead of this, what we can do to avoid such thing is we can create a separate class which is tire vehicles, that will only have function called has only tires. And then there will be a class vehicle, existing class, which already has one function, has motors, and then I will extend this class with tire vehicles, which will override has only tires again. Alright, now if I create a class called car and extend this with vehicle class, it will bring me two functions, has only tires and has motors, and which is true. I mean, car will have both of the things. But at the same time, if I create a class called bicycle, this time instead of extending the bicycle class with the vehicle class, I will extend it with the tire vehicle. I am basically segregating the implementation. I am only using such classes which has only the relevant information or relevant functions available for certain type of vehicles, that is bicycle. So it has only tires, it will not have any motor thing. So of course it will execute something, it will have some functionality, which is fine. Now if I create a main class and I try to create the objects again, one will have the car, which is of type vehicle, one object is of type bicycle, which is of type tire vehicles. So in case if I try to call has motors similar to this object one, right, it will not call, it will not invoke, because there is no function called has motors. So that's the benefit of using LSP, guys, Liskov substitution principle, where if I'm trying to override the functionality of my parent class, I am not altering anything by myself like I was doing here in this case. I am just following the class functions as it is, and I'm trying to execute such functions. Now coming to the fourth principle, that is interface segregation principle, which is also known as ISP. So the definition says that a class should not be forced to implement interfaces it does not use. So we should create smaller specific interfaces rather than a large general purpose one. This prevents classes from being burdened with unnecessary methods. So guys, I think you will always, I mean, you should be knowing this, that there are few classes like on text view clickness, right, which when we overwrite, we have three different functions: on long press, on press, and on double press, something like, right? So most of the times I just use one of the functions, I don't have to use all the three functions. Now that is the issue. Why I have to override all the three functions if I am going to use only one functions out of it? So that is the place where I can make use of this interface segregation principle. I can cut down the boilerplate code, because classes would not longer need to override the unused callback methods. Let's try and see an example how it can be executed. Let's say there is an interface which is known as iWorker. It has two functions, work and eat. Okay, now I create a class robot and I extend it, or sorry, I should be saying I implement this iWorker class, which will has to override these two functions. That is fine, but a robot is not going to eat anything, right? Robot doesn't eat, but it is being forced to implement this function. As I mentioned earlier, similar to the other callbacks, it has to implement something, which is like we are forcing the robot to hey robot, please eat. I know you don't eat, but you have to eat because that is what I want you to do. And at the same time, I create another class called human, which overrides these two functions again by implementing iWorker class, and it will execute like very normally, because human will also, I mean, the human will work, the human will eat. I mean, that makes sense. So robots don't eat, but the interface demands it, so that is the violation. So how this can be avoided is if we segregate the interfaces, like we create two different interfaces, I eat and iWorker, and both of them their own functions. All right, now I create a class robot and I just implement iWorker, which will give me only one function, work. So that is fine. I create another class human, and this time I implement iWorker and I also implement iEat, which will give me both of the functions. So this is based on my convenience, that whichever interface I want to implement, I can make use of it and I can override some certain function or certain functionality, and that would be the place where everything would be lined up very naturally. There will be no fake methods, there will be nothing which will be forced as an implementation, and that is what we call interface segregation principle. All right, now Going to the last and the most important principle, that is dependency inversion principle, which states that the high level modules or the higher level modules should depend on abstractions, not concrete implementation. So I'll explain you in a layman language. What does it means is, let's say we have MVVM as an architecture, we are following it, and then we have view model class, we have repository class, and then we have API interface, right? So the higher level module would be the view model class, and the lower level module would be repository class. If let's say, okay, let's better to understand with an example. What I'm trying to say here is, okay, so we have, I'll just explain in this way. First, repository is this one, repository, yeah, repository, this one. So what I'm trying to say is, let's say we have a view model class, and then we have a repository class, and we have an interface, API interface. Okay, now assuming that if the view model class is injecting the object of the user repository, it is, I mean, sorry, my bad, I am making use of a repository class, but that's what not I meant. I am trying to say here is, instead of repository, what if I use the repository class object itself directly? I'm trying to inject here the user repository function. So the view model basically will not or cannot switch to another data source like fake repository or cached repository or mock repository, because like without changing the code, right? Because I am directly injecting the user repository in as the constructor in the my view model class, and the repository cannot be replaced, decorated or modified without touching the view model class. So both of them are depending on each other. The high level module is completely depending on the low level module. But if I have to follow the dependency inversion principle, which says that the higher level module should not depend on the low level module, rather it should depend on the interface. So what will I do is, I will create an interface, a repository, which will have some function like this, all right, and then there will be a class user repository which will extend the repository interface here. Okay, this is the lower level module which I am making it dependent on the interface this time, all right, and it will override the function, and I will do some function like return API services.get API details. Now when I create the high level module, my view model class, I will just pass the object of the repository class, the interface class, rather than passing the object of user repository, the lower level module. This time I am going to pass the object of the repository, the interface, and I will directly call the method, the get API info. So now the view model basically depends only on a contract, which this is a contract, not on a concrete class. This is a concrete class which I'm not depending on. I'm just depending on the interface. So if I want to add anything new, any new functionality, or I want to return something here like API get API details, instead of this I want to call another function, let's say, and then I want to pass certain more details, I can do that directly into the concrete class. But it will not impact my view model class, because my view model class is basically depending on the interface, right? It's not depending on the lower level module. So that's what the DIP stands for. So guys, this is the final thought. Like, now we know, and I hope you have also understood the meaning of solid principles and how we can avoid violating such rules in our code. And that's pretty much, I mean, if you want me to create more videos on specific questions or any specific topics, you can let me know in the comment section. I'll be happy to do it. Have a great learning ahead, and I'll see you in the next video. Thank you all. Bye.